Students, now in our Fourier series we have already done from 0 to 2 pi, minus pi to pi. Now let's come to arbitrary period. Now arbitrary period means it will be from, like in Fourier series you have studied c to c plus 2 pi. So it will be from c to c plus 2l, right? So now I have the formula of Fourier series as fx is equal to a0 by 2 plus summation an cos n pi x upon n plus summation bn sin n pi x upon L, where a0 is 1 by L, c to c plus 2L fx dx, and an and bn almost same, but only in place of nx now we have n pi x upon L, and the value, limit value is from c to c plus 2L. So if I put c is equal to 0, the limit will become 0 to 2L, and if I put c is equal to some number, say minus L, then it will become minus L to L. So now we have to discuss these two cases. Now here also we will be checking whether the function is even or odd, and the same concepts what we used in the normal Fourier series will be used here. So with this, let us start with the questions. And before starting with that, one more thing we will discuss, that if you have an odd function, okay, how you will check odd function? The same process. If f of minus x is equal to minus fx, it is an odd function. Also, if f of the range is this one, then f of 2l minus x is equal to minus of f of x, then it is an odd function. And in case of odd function, a0 is equal to 0, an is equal to 0, and bn is equal to 2 by L integral 0 to L f of x sin n pi x upon L dx. Okay. Same way if the function is even function, that is f of minus x is equal to fx, or in the other range f of 2l minus x is equal to fx. In that case, a0 is equal to 2 by L integral 0 to L fx dx, and an is equal to 2 by L integral 0 to L fx cos n pi x upon L dx, and bn is equal to 0. So this will be the same as we did earlier. So now let us start with the questions. Now the very first question is, evaluate or expand the Fourier series, expand the function as a Fourier series, and the question is f of x is equal to 2x minus x square, and what is the range given? 0 to 2, right? 0 to 2. So let us work on that, 0 to 2. Now first you always understand, if you compare it with 0 to 2L, so 2L is equal to 2, so L is equal to 1. So in formula, since L is required, it is best to do this. So I can say that it is like 0 to 2 pi, it is a case of 0 to 2L where L is equal to 1. So let me check whether this function is an even function or an odd function. So in place of x, I should put 2L minus x. So 2L is 1 minus x. So let me check, f of 2 minus x is equal to 2, 2 minus x, minus 2 minus x square, right? Because I need to check it in the function, right? So now if I take here 2 minus x common, I am left with 2 minus 2 plus x. Okay, so this is 2 minus x into x, or it is 2x minus x square. So if you observe, I get back the same question. So the function is a even function, right? So in the range 0 to 2, this function is a even function. If it is a even function, I will evaluate a0. The value of a0 will be 2 by L. L is 1. Integral 0 to L. L is 1. And f of x dx. So 2x minus x square dx. Okay. So now integrate it. So this will become 2 is outside. Then x square by 2 and 2 will get cancelled. So x square minus x cube by 3. 0 to 1. So a0 is equal to 2. 1 minus 1 by 3. So 3 minus 1 is 2 by 3. So that is 4 by 3. So a0 value I got as 4 by 3. Now let's move to an. So an is equal to 2 by L. 0 to 1 fx means 2x minus x square cos n pi x upon L. Okay, so now let us integrate this. So as I told you, we can integrate it by parts or by Bernoulli's theorem or by my column method. So 2 minus 2x minus 2, 0. This is sine of n pi x upon n pi. This is minus cos of n pi x upon n square pi square and minus sine of n pi x upon n cube pi cube. Make the cross lines, plus minus plus. So you will have 2 and in bracket 2x minus x square sine n pi x upon n pi, then plus 2 minus 2x cos n pi x upon n square pi square, then the third arrow. So plus 2 sine n pi x upon n cube pi cube. Correct. Now if you observe the limit is 0 to 1. So obviously sine term will go, only cos term you have to put the value. So 2, first you put 1. So 2 minus 2, here if you put 1, 2 minus 2 again 0 gone. So 0 minus, now lower limit is 2, cos 0 is 1 upon n square pi square. So I got minus 4 upon n square pi square as my an value. So what is the answer now? My answer f of x is equal to a0 by 2, that is 2 by 3 plus summation minus 4 upon n square pi square and this is cos n pi x upon L, which is 1. So I am done. This is the answer. Let's come to the next question. Now again it is 0 to 2, means 0 to 2 when I am saying, so 2L is 2, so L is equal to 1. Okay, so now it is a discontinuous function. So in the first part, in place of x I should put 2L minus x. 2L minus x means L is 1, so 2 minus x. So if I put here pi, in place of x I am putting 2 minus x. So is it the second part? Yes, it is the second part. So it is an even function. So even function means a0 you find out, that is 2 by L integral 0 to L pi x dx, because 0 to 1 function is pi x. So 2 pi x square by 2, limit is 0 to 1. So when you put 1 you will get pi. So a0 value is pi. Correct. Now let me check what is an. An is 2 integral 0 to 1 pi x cos of n pi x dx. So 2 pi is out. Now first function integration of second minus integral d by dx of first, double integration of second, cos will become sine, sine will become again cos, cos n pi x upon n square pi square with one negative. So 0 to 1, as I said, it is of no use to put in sine function, so only the second term I will put. Cos n pi is minus 1 to the power n upon n square pi square, minus cos 0 is 1, so 1 upon n square pi square. So my an value is equal to 2 by n square pi minus 1 to the power n minus 1. So my final answer fx is equal to a0 by 2, that is pi by 2, plus 2 upon, summation 2 upon n square pi minus 1 to the power n minus 1 and cos of n pi x. Right. So this is how I can find out the Fourier series for this function. Okay, come to the next question now. Express the function as Fourier series. Okay, fine. Now, what is the L value? L value is, if you compare 0 to 2L, so 2L is equal to capital T. So L is equal to T by 2 now. Correct. Now let me check whether it is an even function or odd function. So in place of T, see in this question is first of all very important. The other problem is that in this question there will be a lot of confusion because it is small t, capital T, and we are used to of x or the constant. So you have to be very particular in this question. Okay. So now if in place of x, x means here t, I should put 2L minus x. Okay. So 2t by 2 minus t. So if I substitute that, so what I am getting, so E, and in place of t I am putting t minus t upon capital T. So it became E minus et by t, but it is not at all related to the given function, right? So I can't find out whether the function is a even function and a odd function. So I have to calculate all the terms, right? So let us start with all the terms. First, a0. So a0 is equal to 1 by L. Remember, when I am not using the concept of even and odd, it is not 2, it is 1 in the formula. Okay. So what was L? L was equal to t by 2. Correct. So 1 by L, so t by 2. Integral 0 to L means t by 2. Right? Not 0 to L. See again here, since I am not using even and odd concept, so it will remain 0 to 2t, right? So 2t is t f of x dx. So et upon t dt, right? So this will become 2 by t, okay, and then e will come out as a constant, t will come out as a constant. Integration of t will be equal to t square by 2 with the limit 0 to t. So a0 value is equal to 2e upon t square and then into 2 and capital T square. Okay, so capital T got cancelled, 2 got cancelled, and I got a0 value as equal to capital E. Right. So now we will evaluate the value of an. So an is 1 by L again, 0 to 2L, et upon t cos n pi t upon L. So L is t by 2. Correct? So now dt. So I am doing it slowly because of the confusion of this t and t. So I don't want to do the mistake. So I am doing very slowly this question. So now let us take out whatever is a constant. So small capital E I can take out, and this capital T also I can take out. So it becomes t square integral 0 to t. So I have now t cos of 2n pi t upon t. This is the part of theta. So I can't take it out. Okay. So now integrate it. So 2e upon t square, first function, integration of sine okay, minus integral d by dt of first function, so t went, and 2 time integration of cos is, cos will become sine, sine will become again cos, but this will become plus cos of 2n pi t upon t and t upon 2n pi square, and limit 0 to t I have to put. So let me put the limit, let me check what I get. So in the sine term if I put t, it is gone. So only in cos term I should put. So t square upon 4n square pi square cos 2n pi t. So capital T if I will put, to capital T and capital T will get cancelled, to cos 2n pi is what? 1 minus. Now when I put 0, I will get t square upon 4n square pi square, cos 0 is 1. So that is gone. Right. So now what is the value of an I got? The value of an is coming as 0. Right. Now let's move to bn. So bn is equal to again 1 by L integral 0 to t fx. Fx is what? Fx is e t by t sine of n pi x upon L dt. So here again 2 by t square e integral t sine of 2n pi t upon t dt. Let me integrate it. So 2e upon t square. So for 0 to t is the limit. First function, integration of second is t upon 2n pi because of sine minus cos of 2n pi t upon t minus sine will become cos, cos will become sine again. So this will become t upon 2n pi square sine of 2n pi t by t, limit 0 to t. So now this will become 2e by t square. Now put first t here. So this will become 1. So minus t square upon 2n pi, okay, cos this is sorry, when you are putting t, capital T get cancelled, 2n pi is 1. So that cos term is to gone. So minus, now I'll put 0. When I put 0, because of this t, it will become 0. So this will become 2 will get cancelled. T square get cancelled. So minus e upon n pi is the value of my bn. So what will be the answer? F of x is equal to a0 by 2. Now what was my a0? E. So this will be e by 2 plus an became 0, summation bn. So minus e upon n pi sine n pi x upon L, L is t by 2. So this is the answer. Same way I can do this question, find the Fourier series expansion. Since mod x I have already done in the previous minus pi to pi range. So just see this, this is an even function, so bn will become 0. Find out a0 by formula and find out an by formula. So pause the video, solve it yourself. Okay, same way this type of question also I have done. So I have just written the answer for your reference so that you can cross check the question. Now look at this question. It is a discontinuous function, right? Now what is L here? See, it is from minus 3 by 2 to 3 by 2. So clearly L value is 3 by 2. And it is a discontinuous function. So in the first part you put x is equal to minus x. So 1 minus 4x by pi is the second part. So this is an even function. If it is an even function, bn is 0 and a0 is equal to 2 by L. And L is your 3 by 2. Integral 0 to L. So 0 to 3 by 2. Okay. Then fx dx. Fx is what? 1. In this range 0 to 3 by 2, fx is 1 minus 4x upon pi dx. So this become 4 by 3 and x minus 4x square by 2 pi 0 to 3 by 2. So this is 4 by 3, 3 by 2 minus 2 by pi, 3 by 2 ka square. Okay, minus 0 when you put it becomes 0. Actually students, this question in your question bank there is a mistake. It has to be 3 here. Otherwise you will get such weird answers. If it is 3, easily you will get your a0 is equal to 0. So change this question to 4x by 3 and 4x by 3 also here. So when you solve, your a0 value will be 0 and your an value will be equal to minus 4 upon n square pi square minus 1 to the power n minus 1. Okay, so when you will solve this, you will get a particular, or you will solve for odd values, you will get it as 8 upon n square pi square. So there is a change in this question, so you just change it and then you solve this question. So I hope with this you have cleared your all the doubts about Fourier series. Now the next topic will be your half range series, where I have a restriction of extending the function in only sine terms or only cos term, which I will be covering in my next video. I hope you like it. So please share it and subscribe the channel so that you will get the updates, you will get the notification the moment I will upload a new video. I am also planning to have a YouTube live classes. So be connected with me, subscribe the channel and share the channel to as many as students as you can. Thank you.